Hi, I'm Archibald Biclaro, and today we're going to solve some problems that involves the topics of Calculus 2. So without further ado, let's start and solve some problems. Now let's start with our first problem. We have here, given the region bounded by the graphs of y is equal to ln x, y is equal to 0, and x is equal to e. Find A, the area of the region, B, the volume of the solid generated by revolving the region about the x-axis, C, the volume of the solid generated by revolving the region about the y-axis, D, the centroid of the region. As you can observe, our first problem involves finding the area, the volume, and the centroid. So let's start with letter A, finding the area of the region. We have y is equal to ln x, y is equal to 0, and x is equal to e. So in finding the area of the region, we must first have an illustration, or we must first graph the function. So I already sketched the graph of the function y is equal to ln x. There is the graph, here is the graph. So this line is our y is equal to ln x, and as you can observe, the ln x is intersecting the x-axis at 1, and in our given we have x is equal to e, so our e is equivalent to approximately equal to 2.7. So here, this is our e. Now, the region, this is the region from e to x is equal to e. Now we must find the area of this region. So let's start to solve it by using the formula in finding the area of the region. So we have a formula. So then area is equal to integral of a to b f of x dx. This is now our formula. Now a is equal to integral of, we all know that a, let's go back to our graph. As you can see, our graph, y is equal to ln x intersects x at 1. So 1 here is our a, and our b is e. So therefore, our a here is 1, and our b here is e. Now our f of x is ln x dx. Now, as you can observe to our problem, we cannot integrate it directly. So in integrating it, we must use the integration by parts. So as you can remember, the formula in integration by parts, the formula of integration by parts is we have u times v minus the integral of v du, right? So we are going to let u is equal to ln x, and du is equal to derivative of ln x, we have 1 over x. Don't forget the dx. Our dv is equal to dx, and our v here is equal to x. Now let's substitute this into our formula of integration by parts. So u we have ln x times v is x minus the integral of our v is x, our du is 1 over x dx. Now let's copy this to our solution. So a is equal to this one, ln x times x minus integral of x times 1 over x dx, the lower limit 1 and the upper limit e. Now a is equal to ln x times x, we have x ln x minus, we all know that x times 1 over x is equal to x over x, right? x over x is equivalent to 1. So therefore, the remaining is only dx, or 1 dx. 1 e. Now, x ln x, and the integral of dx is x. 1 to e. Next, let's substitute our upper limit minus the lower limit. We have upper limit e ln e minus e, minus our lower limit, we have 1 ln 1 minus 1. So area is equal to, we know that ln e is equivalent to 1. So e times 1 minus e minus 1. We all know that ln 1 is equal to 0 minus 1. A is equal to e times 1 is equal to e minus e, minus 1 times 0 is 0, minus 1, so negative 1. Now, e minus e, well, 0. Negative times negative, we have positive 1. Now, our area here is 1. Therefore, the area of the region is 1. Now let's proceed to our letter B. Find the volume of the solid generated by revolving the region about the x-axis. Y is equal to ln x, y is equal to 0, and x is equal to e. In previous letter, in finding the area, we already graphed the function y is equal to ln x. But in this letter B, we will going to revolve or to rotate the region into our x-axis. So I have here an illustration to our function y is equal to ln x. As you can observe, this is our y is equal to ln x, right? And it intersects at x-axis at 1. And x is equal to e. This is our given. E is approximately equivalent to 2.7. So here, and this region, this is the region, right, from 1 to e. We will going to rotate this region in our x-axis. So we will it can form, so since we will going to rotate it, it can form now a what we call disk. Therefore, in finding the volume of the solid generated by revolving the region about the x-axis, we will use the disk method. And the formula for the disk method is volume is equal to pi integral of a to b f of x squared dx. This is the formula for the disk method. Now again, our a here is 1 and our b is e, and our f of x here is ln x. So let's substitute to our formula. So v is equal to pi, our a is 1, our b is e, f of x is ln x squared dx. Now v is equal to pi. Now let's integrate this ln x by using the integration by parts. So let's integrate this. Again, our formula for integration by parts is u v minus the integral of v du. So we are going to let u is equal to ln x squared, and our du, the derivative of ln x squared is 2 ln x. Ln x we have 1 over x, so 2 ln x over x. Don't forget the dx. And our dv now, we have the dx. And our v is equal to x. Now, let's substitute to our formula. So, our u is ln x squared, right? Ln x squared times our v is x minus the integral of our v is x and our du is times 2 ln x over x dx from 1 to e. Now, let's proceed. V is equal to, we have copy the pi, ln x squared times x is x ln x squared minus x times integral of x times 2 ln x over x. We have ito magiging cancel to, diba? So 2 ln x dx. And don't forget 1 to e. V is equal to, copy again the pi, also copy x ln x squared minus, since we have constant 2, we will going to put it outside the integral. So 2 the graph of ln x dx. 1 is to e. Now, let's proceed. V is equal to, copy the pi, x times ln x squared minus 2. Now, the derivative of ln x dx, we already solved it in the previous letter, which is letter A. So the integral of ln x is x ln x minus x. The integral of ln x dx is x ln x minus x. 1 to e. Now let's proceed. Let's distribute 2 to our here inside the parentheses. So it will looks like this. We have copy v is equal to pi x ln x squared minus 2 times x ln x. We have 2x ln x minus negative 2 times negative x. We have positive 2x. Don't forget the 1 to e. Now let's focus here. Now let's substitute the upper limit minus the lower limit. So we have v is equal to pi e ln e squared minus 2e ln e plus 2e minus pi, again our lower limit. We have 1 ln 1 squared minus 2 times 1 ln 1 plus 2 1. This is 1, sorry. That is 1. Next, simplify. We have v is equal to, copy again the pi. We all know that ln e is 1, right? And 1 squared is 1. And e times 1 is e minus, again ln e is 1. So 1 times 2e is 2e, magiging 2e plus, copy the 2e, minus pi. We'll know that ln 1 is 0, right? And 0 squared is 0. 0 times 1 is 0. Minus 2 times 1 is 2. And ln 1 is 0. Therefore, 2 times 0. Plus 2 times 1 is 2. V is equal to pi, copy again the pi, copy the e, and negative 2e plus 2e cancel. So remaining is e minus pi. 0 minus 2 times 0 is 0. 0 minus 0 is 0 plus 2, so 2. So therefore, v factor ito, we have pi e minus 2. This is now our final answer. Therefore, the volume of the solid generated by revolving the region about the x-axis is pi 2. Now let's proceed to our letter C. Find the volume of the solid generated by revolving the region about the y-axis, where y is equal to ln x, y is equal to 0, and x is equal to e. Now, in the previous letter, we already graphed the y is equal to ln x. Now, to visualize what we are going to find, where we're going to find the volume of the solid generated by revolving the region about the y-axis, we must illustrate it by graphing it again. So, I already sketched the graph. Explain ko na lang. So, here is the ln x. As you can see, this is the ln x. Now, and x is equal to e here. And this dark one is the region of the graph of y is equal to ln x. Now, if this region will rotate into our y-axis, since this is our y-axis, so it looks like this, ganito. It will rotate to the y-axis. It will rotate to the y-axis. It can create a cylindrical shell. As you can see, if it will rotate, this region will create a solid that is cylindrical shell. Now, since it will create a cylindrical shell, now let's use the shell method. Now, the formula for shell method is volume. The formula finding the volume by using the shell method is volume is equal to 2 pi integral from a to b rx, or what we call the radius x times height x, right, dx. This is our formula in finding the volume by using the shell method. Now, what is our radius and what is our height? Now, let's go back to our graph. Since it will create a cylindrical shell, now the radius is from the center to the what do you call this? The boundary, or the boundary. Since the graph intersect at x is equal to e, 2 point, since in the given x is equal to e. So now from 0 to x is equal to e, that is now our radius. Our radius is x, since x is equal to e, so our radius is x. Now our height, since this is our radius and this is our height, so our height is the graph ln x. So our height is ln x. And again, our lower and upper limit is from 1 to e. A is 1 and b is e. Now let's substitute this equation to our problem. Now v is equal to, copy the 2 pi, integral of our a is 1 to e, or rx, which is the x, our radius is x, times the height, which is the ln x, copy dx. Now, since we have already substituted, now let's integrate. Now, how we're going to integrate this one? To integrate this one, let us use the integration by parts. So, let's have another paper. To integrate this equation by using the integration by parts, so we're going to let u is equal ln x, and our du will become dx, since ito x, right, dx over x, since 1 over x, ln x is 1 over x, right, derivative of ln x. Next is the dv, our dv is dx dx, and our v is x squared over 2. Now let's put this into our problem. So copy again the 2 pi. Now, again, the formula for integration by part is u v minus the integral of v du. Let's use this formula into our problem by substituting this into our formula. So our u is ln x, and our v is x squared over 2 minus our v again is x squared over 2, integral pa rin, don't forget the integral, x squared over 2, and our du is dx over x. Now, let's proceed. Don't forget the lower and upper limit. Next, let's multiply, copy the 2 pi. Now, ln x times x squared over 2, it is the same as x squared ln x over 2 minus, copy the integral sign, let's multiply this. As you can see, it has a constant 1/2, right? So let's put 1/2 outside integral. 1 over 2 integral. So magiging x squared, and we have x here at the denominator, so we can cancel. So remaining is x dx, right? X dx. So we can integrate the x dx easily. Don't forget again the upper and lower limit. So copy the 2 pi, copy the x squared ln x over 2 minus our 1/2. Now the integral of x dx, which is x squared over 2. Don't forget the e and 1. Now let's multiply this 1/2 times x squared over 2. So copy again the 2 pi. X squared ln x over 2 minus 1/2 times x squared over 2, which is x squared over 4. 1 and e. Now let's substitute our upper limit minus the lower limit to our this expression. So copy the 2 pi. Now let's start with our upper limit, which is e. So e squared ln e over 2 minus e squared over 4 minus our lower limit. Copy firstly 2 pi, which is again 1 squared ln 1 over 2 minus 1 squared over 4. Now simplify. So copy again the 2 pi. E squared ln e, we know that ln e is 1, right? So the remaining is e squared over 2. So e squared over 2 minus, copy the e squared over 4, and minus, copy the 2 pi. Now 1 squared is 1, or ln 1 is 0, right? And 1 times 0 is 0, and 0 over 2 is 0. So it will become 0 minus 1 squared is 1, so 1/4. Still 1/4. Next, copy the 2 pi. Now let's subtract this, since our we have our denominator is 2 and 4, and the LCD for this is 4, so we will use this as our denominator. So 4 divided by 2, which is 2 times 2 times e squared, we have 2e squared, and for that minus 4 divided by 4, which is 1 times e squared, which is e squared, minus 2 pi, since 0 minus 1 over 4 is 1 over 4, still 1 over 4, negative 1 over 4. Now copy again the 2 pi, 2e squared minus e squared, so for this, over 4. Since we have negative here, and 2 pi times 1/4, and negative 1/4 is negative, and negative times negative, which is positive, so magiging positive 2 pi 1 over 4. So just to subtract yun, sorry. So 2 pi 2e squared minus e squared, which is 2e squared minus e squared, which is e squared, since it has a constant 1 here. So 2 minus 1, which is 1, so only e squared over 4 plus 2 pi 1 over 4. So our final answer is 2 pi, ano, let's add this muna. So magiging 2 pi e squared plus 1 over 4. Since 2 pi divided by 2 pi times e squared plus 1 over 4, no, magiging pi times e squared plus 1 over 2. Now this is now our final answer, which is pi e squared plus 1 over 2. Now let us proceed to our letter D, which is find the centroid of the region y is equal to ln x, y is equal to 0, and x is equal to e. In finding the centroid, we must graph the y is equal to ln x and find its region. So since we already graph the y is equal to ln x, let's go back to the graph that we used in letter A. So this is the graph in letter A. This is our y is equal to ln x, and this is the x is equal to e. This is the region. This is the region of y ln x. Now let's find the centroid of the region, or the center or centroid of the region. Now to find the centroid, let's have a formula. So the centroid is mean of x, or the x coordinate of center of mass, and mean of y, or the y coordinate of center of mass, is equal or same as, to find x, or the mean x, or the x coordinate of center of mass. To find that, we will use the moment of y axis over a, or the area, or a here is our area. And to find the mean of y, or the y coordinate of center of mass, we'll use the moment of x axis over our area. Now again, our area here, we already calculated the area, which is area is equal to 1. Now let's go back here, where my over a and mx over a. To find my, this my, since we already have the area, to find my, let's use the formula for integral a to b, where x f of x dx. And for mx, moment of x is equal to integral of a b 1/2 f of x squared dx. Now, since our formulas are ready, let's start by finding first the moment of x. Let's find the moment of x. So find moment of x, where moment of x is equal to our formula, which is a to b 1/2 f of x squared dx. Now is equal to, since integral, again our a here is 1 and our b is e 1/2. Since our f of x here is the ln x, we have ln x squared dx. Let's put the constant 1/2 outside integral, so 1/2 1 to e ln x squared dx. So let's integrate the ln x squared. So to find the integral, let's use again the integration by parts, where, let's use another paper for integration. So again, the formula for integration by parts is u times v minus the integral of v du, where u, so we're going to let u as our ln x squared, and our du here is, derivative of this is 2 ln x over ln x, which is 1/3, so x dx. And our v, dv, which is, remaining is dx, and integral of, or the v, which is x. Now let's substitute this to our formula. Let's put this into our problem. So 1/2 integral of u, which is ln x squared ln x squared times our v, which is x, minus the integral of v, which is again x, and our du, which is 2 ln x over x, so times 2 ln x over x. That is our du. Now, don't forget the dx and our lower and upper limit. Now, let's proceed. Is equal to, copy the 1/2 ln x squared times x. We have x ln x squared minus, since we have 2 here, constant 2, let's put that outside integral. 2, since x times 2 ln x over x, so cancel the x. Remaining is ln x dx. Don't forget the 1 and e. Next, let's integrate the ln x dx since we already found the integral of that. So, copy again the 1/2 x ln x squared minus 2 times the integral of ln x dx, which is x ln x minus x 1 e. So next, let's distribute 2 1/2, copy the x ln x squared minus, let's distribute 2 to our expression inside of our parentheses. So we have negative 2 times x ln x, which is negative 2 x ln x, negative 2 times negative x, which is positive 2x 1 is to e. Next, let's use another paper. So let's copy this one. So we have equal to 1/2 x ln x squared minus 2x ln x plus 2x e1. Now let's focus here. So let's substitute our upper limit to our x minus our lower limit, which is 1. So 1/2. Substitute e to our x, so we have e ln e squared minus 2e ln e plus 2e minus 1/2 our lower limit, which is 1 ln 1 squared minus 2 times 1 ln 1 plus 2 1. So let's simplify it. So 1/2, copy 1/2, copy e, since ln e is 1 and 1 squared is 1, so let's copy e minus 2e ln e, since again ln is 1, so it will remain 2e plus 2e minus 1/2 ln 1 is equivalent to 0, and 0 squared is 0, and 0 times 1 is 0, minus 2 times 1, which is 2, and ln 1, again it is 0, so 2 times 0 is 0, plus 2 times 1, which is 2. So 1/2, as you can see, we have but negative 2e plus 2e, so we can cancel it. So e, and we have here minus 1/2 positive 2. So we can write it as e minus 2 over 2. This is now our moment of x axis. So this is our mx. Now, to find, since we already have the moment of x, or the moment of x axis, which is equivalent to e minus 2 over 2, now we can solve for, mean of y. So, mean of y, solve for mean of y, which is y is equal to moment of x over the area, since our area is equal to 1 and our mx is equal to e minus over 2, so we have y, mean of y is equal to e minus 2 over 1. So we have y mean of y, which is e minus 2 over 2. We have now the y coordinate of center of mass. Now let's find the x coordinate of moment of mass, or the m of x, by finding first the m of y. So let's calculate for m of y. Let's use another paper. So to solve for find m of y, moment of y, we have our formula, which is ito, my is equal to the integral of a to b x f of x dx. Now let's have, again, our a is here is 1 and our b is e, copy the x, and our f of x is ln x. Don't forget the dx. Now let's integrate. So we can use the integration by parts. The formula for integration by parts is u b minus the integral of v du. Now we're going to let u as ln x. And our du now is dx over x. And our dv, which is x dx. Now our v now is x squared over 2. Now let's substitute to our formula. So integral of from 1 to e. Let's use the no. Let's copy again. dx. We have ub minus the integral of v du, which is our u is ln x, times our v is x squared over 2, minus the integral of v du, or vr is x squared over 2, and our du is times dx over x. Don't forget our lower and upper limit. Now, since we have constant 1/2 here, let's put the 1/2 outside the integral first. So copy, let's multiply now. So ln x times x squared over 2, same as x squared ln x over 2. Minus, again, we have constant 1/2 here, so let's put 1/2 outside the integral. So x squared times dx over x, so we can cancel the x at the denominator. So may x dx. Yan, e to the 1. After this, let us derive this one. So x squared ln x, copy this, minus 1/2 times the integral of x dx, which is x squared over 2, 1 to the e. Now let us multiply this one, so copy x squared ln x over 2, minus 1/2 times x squared over 2, which is x squared over 4, e to 1. Now let's substitute our upper limit e to our x minus the lower limit to 1. So it will be e squared ln e minus a over 2 minus e squared over 4, minus our lower limit, which is 1 squared over ln 1 over 2 minus 1 squared over 4. So simplify, we have, since ln e is 1, so remaining is e squared over 2 minus e squared over 4, minus ln 1 is 0, so automatically this expression will become 0, minus 1 squared, which is 1 over 4. So e squared minus 2 minus e squared minus 4, which is, we have the common denominator, or our least common denominator, which is 4. So we have 4, so 2e squared minus e squared. Negative times negative, which is positive, 1/4. So our my, moment of y, so our my is, we can subtract it pa naman, diba? So 2e squared minus e squared, it will become e squared. So e squared plus 1, since we both have 4, so over 4. This is now our moment of y-axis. Now, let's solve for mean of x. Now, to solve for mean of x, just another paper. So To solve for min of x, min of x is equal to moment of y over area. Again, our area is equal to 1. So x min of x, my, which is ito. So e squared plus 1 over 4 over 1. So our min of x is equal to e squared plus 1 over 4. Therefore, we can now identify our centroid. So our centroid is, we have min of x and min of y. And our x, min of x, which is e squared plus 1 over 4. And our min of y, which is ito, e minus 2 over 2. Therefore, this is now our centroid. Therefore, the centroid of the region is e squared plus 1 over 4 and e minus 2 over 2. This is now our answer. Now let's proceed to our second problem, which is find the arc length of the graph of the function over the indicated interval. Our function here is y is equal to x to the fourth over 8 plus 1 over 4x squared with an interval of 1 and 3. Now, since our problem is all about arc length, we need first to graph this function. So I already sketched this the graph of this function, and it looks like this. This blue is our y is equal to x to the fourth over 8 plus 1 over 4x squared. This is our function. And our interval is 1 and 3. These red lines, 1 and 3. Now, we're going to find the length of arc. So, from this 1 and to this 3, the black color is the arc, and we need to find the length of that arc. So, to find the length of this arc, we need to use the formula for finding the length of arc. So the formula for finding the length of arc is length is equal to the integral of lower limit a and upper limit b square root of 1 plus our function dy dx squared dx. This is the formula. Now, as you can see, to our formula, it is required a dy dx. So since it required dy dx, and our function is y is equal to x to the fourth over 8 plus 1 over 4x squared, we need to derive this function. So first, we need to derive this function. So our function is y is equal to x to the fourth over 8 plus 1 over 4x squared. Let's derive. So y prime is equal to derive this x to the fourth over 8, we need to use the quotient rule, which is f prime of x times gx minus fx times g prime x over gx squared. Our fx here is the x to the fourth, and our gx here is our 8. So let's derive. So the derivative of our fx is the derivative of x to the fourth is 4x minus 1 is 3 times our g of x, which is 8, minus our fx, which is x to the fourth, times the derivative of 8, which is 0, over 8 squared. Same process, plus to our 1 over 4x squared. So 0 times 4x cubed squared minus 1 8x over 4x squared to the power of 2. Now let's simplify. So y prime is equal to 4x cubed times 8, which is 8 times 4, we have 32, x cubed minus x to the power of 4 times 0 is 0. Over 8 times 8, we have 64. Plus 0 times 4x squared, we have 0. Minus 1 over 8, 1 times 8x, which is 8x, negative 8x. Over 4x squared to the power of 2, we have 4 times 4, we have 16. 2 plus 2, we have x, 4. Ayan. Now, simplify again. So, 32x cubed minus 0, which is 32x cubed over 64 plus 0 minus 8x, which have negative 8x. Negative 8x over 16x to the fourth. Next is, let's simplify again. Y prime is equal to 32 over 64 is same as 1 half, right? So 1 x cubed over 2 plus, positive times negative, which is negative, right? So it will going to be negative. 8 over 16 is same again as 1 half, right? And x over x to the fourth, we need to subtract the power of the numerator and denominator. So 4 minus 1, we have x cubed. Now x cubed over 2 minus 1 over 2 x cubed. This is now our derivative of our function. Now let's substitute this equation to our formula. So let's begin. L is equal to, again, our lower and upper limit is 1 is our lower limit, which is a, and our 3 is our upper limit, which is b. So let's substitute 1 and 3. Square root of 1 plus our dy dx, which is this one. We have x cubed over 2 minus 1 over 2x cubed square dx. Now, as you can see, we have square of binomial, need to expand. So L is equal to 1, 3, 1 plus, let's expand this one. So, the other sheet of paper, we have x cubed over 2 minus 1 over 2x cubed times x cubed over 2 minus 1 over 2x cubed. So let's use the FOIL method. This one is x to the power of 6 over 2 times 2, which is 4. And to the other side, we have negative x cubed over 4x cubed. That is 1. Negative 1 over 2x cubed times x cubed over 2, we have same as x cubed over 4x cubed. Minus, negative times negative, we have positive 1 over 4, 2 times 2, 4, x cubed times x cubed, which have x to the power of 6. Now let's simplify. X to the power of 6 over 4. We have here x cubed over 4x cubed, right? So it cancel. So in 1/4 minus same as here, 1/4 plus 1 over 4 x to the power of 6. Sorry, 6 here, 6. Next, x 6 over 4. Negative 1/4 minus 1/4, we have negative 1/2 plus 1 over 4x to the power of 6. Now this is the expanded one. So copy here to our solution. We have x6 over 4 minus 1/2 plus 1 4x to the power of 6 dx. Now let's continue. So we have constant 1 and negative 1 up. Let's combine. So copy the integral 1 to 3 square root of 1 plus negative 1/2, which is 1/2, right? So copy x to the 6 over 4 positive 1/2 plus 1 over 4x to the power of 6. Don't forget the dx. As you can see, we can factor this one, and if we will going to factor this one, it is the same as L is equal to 1, 3. If we're going to factor that one, we'll go back to our x cubed over 2 But this time, it is positive because nagiging positive 1 half na siya dito. Kaya naging 1 half. Negative 1 half man, right? So, naging negative. So, positive 1 half na siya. So, magiging positive na din dito. And 1 over 2x cubed squared. Don't forget the dx. So, next, let's proceed. L is equal to integral of 1 to 3. Now, as you can see, we have squared and square root, so you can cancel it. So, magiging x cubed over 2 plus 1 over 2x cubed dx. Now, we can separate these two fractions. L is equal to integral 1 to 3 x cubed over 2 dx plus integral of 1 to 3 1 over 2x cubed dx. Since we have constant here, we will move the 1 half. We have constant 1 half, right? So we need to put this constant outside the integral. So L is equal to 1 over 2 integral of 1 to 3 x cubed dx plus, again, put 1 half outside integral. So 1 half integral of 1 to 3 1 over x cubed dx. So let's copy this one. So L is equal to 1 half 1 to 3 x cubed dx plus 1 half integral of 1 to 3 1 over x cubed dx. Now let's focus here. So let's continue this one. Let's integrate 1 half integral of x cubed. We have x to the fourth over 4 1 to 3 plus 1 half integral of 1 over x cubed. 1 over x cubed is same as x to the power of negative 3, right? So negative 3 plus 1, we have negative 2. So x negative 2 over negative 2. Yan. 1 to 3. So substitute the upper and lower limit. So L is equal to 1 half. We have our upper limit. 3 to the fourth over 4 minus 1 to the fourth over 4 plus 1 half. 3 to the power of negative 2 over negative 2 minus 1 negative 2 over negative 2. Simplify. We have 1 half. 3 to the fourth. We have 81 over 4 minus 1 over 4 plus 1 half. 3 to the power of negative 2, which is 1 over 9. 1 over 9 divided by negative 2, which is negative 18. And sorry, negative 1 over 18 minus, we have negative, 1 to the power of negative 2 over negative 2, which is negative 1 half. So simplify again. L is equal to 1 half. 81 over 4 minus 1/4, we have 81 over 4 minus 1/4, we have 20 plus 1 half, negative 18, negative 1 over 18, 1 over 18 minus 1 half, we have negative 5 over 9. So let's multiply. 1 half times 20, we have 10 plus, I think, wait lang, 1 to the power of negative 2, negative 2. So dapat magiging negative 1 half ito, diba? So minus, dapat niya ito pa. Sorry, I forgot. And magiging may negative 1 over 18 plus 1 half dapat dito. Plus 1 half, so magiging wait lang, negative 1 over 18 plus 1 half. We have 4 over 9. Here, 4 over 9. Sorry. 4 over 9. So 1 half times 4 over 9. We have 2 over 9. And 10 plus 2 over 9. We have 10 plus 2 over 9. Which is L is equal to 92 over 9. I'm so sorry if I forgot the grouping symbol here. Kaya naging mali yung result natin dito. But we corrected it, so nagiging 4 over 9, and we came up to the answer of 92 over 9. So that is the length. Therefore, the length of the arc length is 92 over 9. Now, let's proceed to our third problem. A force of 250 Newton stretches a spring 30 centimeter. How much work is done in stretching the spring from 20 centimeter to 50 centimeter? As you can observe to our problem, it is a work problem. Specifically, it talks about stretches a spring. So since it is stretches a spring, we will use the Hooke's law. And the formula of it is F is equal to Kx, where F is the force, K is the constant, spring constant, and X is the displacement. Now let's identify the given. Now our force, which is our F, is equal to 250 Newton. And our X, which is our displacement, so we have X is equal to stretches a spring 30 centimeter, so 30 centimeter. Now, Newton is 1 Newton is equivalent to 1 kilogram meter per second squared. Since Newton is 1 kilogram meter per second squared, let's convert centimeter into meters. So we have 30 centimeter is equivalent to 0.3 meters. Next, we have K, our spring constant, which is we need to find the spring constant. Next is we have stretching the spring from 20 centimeter to 50 centimeter. So we have lower and upper limit. So we have our A here is 20 centimeter. Converted into meters, we have 0.2 meters. And our B, which is 50 centimeter, converted into meter, we have 0.5 meters. Now, let's put these values to our Hooke's law formula. So F is equal to Kx. Since we don't have K, let's find the K constant by using the Hooke's formula. So F is equal to 250 Newton is equal to K times our displacement. We have 0.3 meters. So let's find the value of K. Divide 0.3 both sides. Instead, K is equal to 250 divided by 0.3. We have 250 divided by 0.3, which is 833.33. The unit is Newton per meter. This is now the value of our K. Now, since we have the value of K and the problem is to find the work, so the formula for work, which is work is equal to integral of A to B f x dx. Now, to find the work, let's substitute the values. So we have A and B, which is we have A is 0.2 meters and our B is 0.5. Fx, since our F here is our K, so which is 833.33. And we don't have X, we have X dx. Next, let's put our constant outside the integral. So 833.33 integral of 0.2 0.5 x dx. Now let's integrate. Copy the constant what is the integral of x dx? So we have x squared over 2, 0.2 to 0.5. Now let's substitute the limit. So we have, let's have an extra here. So is equal to 833.33 x squared over 2. So let's substitute. So we have x squared, so we're getting 0.5, since this is 0.5 is our upper bound. So squared over 2 minus, copy 833.33. We have our lower limit, so we have 0.2 squared over 2. So 833.33, 0.5 to the power of 2 is equivalent to 0.25. 0.25 over 2 minus 833.33, 0.2 squared, which is 0.04 over 2. Next is 833.33 times 0.25 over 2 is equivalent to 1/8, right? Minus 833.33 times 0.04 over 2 is equivalent to 1 over 50. So let's multiply 833 times 833.33 times 1 over 8 is equivalent to 8,333 over 800 minus 833.33 times 1 over 50 is equivalent to 83,333 over 5,000. So let's subtract. So we have 83,333 over 800 minus 83,333 over 5,000 is equivalent to 87 point, since 49, let's round up, so again 87.5. The unit is joules. This is now our final answer. So therefore, in stretching the spring from 20 cm to 50 cm, the work is done is 87.5 joules. Now let us proceed to our fourth problem. We have integrate the integral of x cubed over square root of 4 plus x squared dx. A is by integration by parts, letting dv is equal to x over square root of 4 plus x squared dx. And b is by substitution, letting u is equal to 4 plus x squared. So let's start with letter A. Letter A is by parts, letting dv is equal to x over square root of 4 plus x squared dx. And this is our problem, the integral of x cubed over square root of 4 plus x squared dx. Now, to integrate by parts, we have formula, diba? So our formula is u, in integrating by parts, integration by parts, we have a formula u times v minus the integral of v du, right? This is our formula for the integration by parts. Since we have already dv, since our dv is x over square root of 4 plus x squared dx. Now, we all know that the integral of dv, or the antiderivative of dv, is our v, right? So let's integrate this equation to get v. So v is equal to integral of x over square root of 4 plus x squared dx. Now, to integrate this, we're going to let p is equal to 4 plus x squared. And the derivative of rp, dp, is equal to 2x dx. Since we have x dx here, let's divide both sides by 2. So magiging dp over 2 is equal to x dx. Now let's use this to our equation. So v is equal to integral of our x dx, which is our dp over 2, dp over 2, and square root of 4 plus x squared, since our 4 plus x squared is p, same as square root of p, right? As you can see, we have constant here, which is 1/2. So let's put 1/2 outside the integral. 1/2 integral of dp over square root of p. Now, square root of p is same as p, so 1/2, right? To the power of 1/2. Now, since it is placed on the denominator, let's put it into the numerator by making the power making it negative. So magiging v is equal to 1/2 integral of p negative 1/2. So dp. So let's integrate this. So 1/2 integral of p to the power of 1/2 dp. P negative 1/2 plus 1 is equal to 1/2 over 1/2. Now, since 1/2 times p to the power of 1/2 over 1/2, cancel. So magiging v is equal to p 1/2. And v is equal to p to the power of 1/2 is same as v is equal to square root of p, and our p is 4 plus x squared. So our v is square root of 4 plus x squared. So now we have v. Our v is 4 plus x squared. Now, since we have v and dv, but we don't have u and du, now let's go back to our problem. This equation is same as x squared x over square root of 4 plus x squared dx. Since our dv is x over square root of 4 plus x squared, and our v is 4 plus x squared, so we have x squared, right? So we're going to let that x squared be u. So our u is x squared. And our du, the derivative of x squared, is 2x dx. Now let's use this and substitute to our formula. Since we have uv minus integral of v du, so our u is x squared times our v, which is no, I forgot the square root here, since this is our v. So our v is square root of 4 plus x squared minus, again, the integral of our v, since our v is square root of 4 plus x squared, and our du is 2x dx. 2x dx times 2x dx. Now, let's focus to this. Next, x squared times square root of 4 plus x squared. So magiging x squared 4 plus x squared minus integral of square root of 4 plus x squared times 2x dx is same as 2x square root of 4 plus x squared dx. Now, to integrate this one, let's copy first the x squared square root of 4 plus x squared minus, to integrate this, let's going to use substitution again. So we're going to let another variable, let's say let r is equal to 4 plus x squared, and our dr is equal to 2x dx. Now let's substitute this to this. Now, since we have 2x dx, this is our dr, right? And our square root of 4 plus x squared, this is our r, since 4 plus x squared, so magiging square root of r. Don't forget the integral sign. Now, since we have a new equation, let's integrate this. Copy x squared square root of 4 plus x squared minus, again, the square root of r is same as r to the power of 1/2, right? So let's make it r 1/2 dr. So copy x squared 4 plus x squared minus the integral. So let's integrate. So r to the power of 1/2 plus 1 is equal to r to the power of 3 over 2 over 3 over 2 plus c. Don't forget the plus c. Next, we have copy again the x squared. We have x squared, square root of 4 plus x squared, minus, since, as you can see, 2 over 3, let's put it to the numerator but by its reciprocal, so magiging 2 over 3 times r 3 over 2 plus c. Now, copy again the x squared, square root of 4 plus x squared, minus 2 over 3. Remember the value of r. Eto. R is 4 plus x squared, right? So let's substitute. So magiging 4 plus x squared to the power of 3 over 2 plus c. So our final answer is x squared, the square root of 4 plus x squared minus 2 over 3, 4 plus x squared to the power of 3 over 2 plus c. This is now our final answer by using the integration by parts. Now let's proceed to our letter B by integration by substitution. Letting u is equal to 4 plus x squared. And this is again our problem. Integral of x cubed over square root of 4 plus x squared dx. So since we already have u, since our u here is 4 plus x squared, and our du, the derivative of it, is 2x dx. Now, as you can see, this equation is same as integral of x squared times x over square root of 4 plus x squared dx, right? So let's find x dx. So to find x dx, let's divide this to 2. So du over 2 is equal to x dx. Next, since we have x squared, and also we have u is equal to 4 plus x squared, to find the value of x squared, so let's x squared is equal to add both sides by negative 4. So magiging u negative 4 minus 4. So let's use this one to integrate our problem. So substitute. Our x squared is simply u minus 4 over our square root of 4 plus x squared. Since our 4 plus x squared is u, so we're going to square root u. And our x dx is same as d over 2. Since we have 1/2, let's put this constant to outside the integral. So giving 1/2 integral of u minus 4 over square root of u du. Now since it has a common denominator, let's separate this numerator. So magiging 1/2 integral of u over square root of u minus 4 over square root of u du, right? Next, since square root of u is same as u 1/2, negative 1/2, sorry, so is equal to 1/2 integral of u times u to the power of negative 1/2 minus 4 times u to the power of negative 1/2 du. Now, since it has a common base, u times u to the power of negative 1/2, and since we are going to add the exponent, since u, it has a 1 to its exponent, so 1 plus negative 1/2, so magiging 1/2 integral of u, 1 plus negative 1/2, we have 1/2, minus 4 times u to the power of negative 1/2, so magiging 4 u to the power of negative 1/2. Don't forget the du. Next, let's separate 1/2 integral of u to the power of 1/2 minus integral of 4 u to the power of negative 1/2. Don't forget the du here and du. Next, since we have constant here, let's put it outside of the integral. So 1/2 u to the power of 1/2 du minus 4 integral of u to the power of negative 1/2 du. Now let's integrate. So 1/2 integral of u to the power of 1/2 is u 1/2 plus 1 is 3 over 2 over 3 over 2. minus 4 integral. We have u to the power of negative 1 half plus 1. You have same as 1 half over 1 half. Don't forget d plus c. Now, 1 half times, since it has 3 over 2, let's multiply this 1 half to its reciprocal. We have 2 over 3. We have u 3 halves minus 4 times 1 half is same as 4 times 2 u 1 half plus c. So is equal to 1 half times 2 over 3 is same as 1/3. And copy the u 3 over 2 minus 4 times 2 is 8 u to the power of 1 half plus c. So again, since the value of our u is 4 plus x squared, so let's substitute the 4 plus x squared to our u. So magiging 1/3, our u is 4 plus x squared, 4 plus x squared, and our exponent is 3 over 2 minus 8. Again, our u is 4 plus x squared, and our exponent is 1 half plus c. And this is now our final answer. Now, let's proceed to our fifth and last problem. We have here integrate the integral of secant squared x over tan squared x plus 5 tan x plus 6 dx. Now, first thing we must do is to observe our problem. As you can see, we have, in our denominator, we have tan squared x or tan x, right? And the derivative of tan x, we have secant squared x, which is our numerator. So, to solve this problem, we can let u is equal to tangent x, and the derivative of tangent x du is equal to secant squared x dx. Now let's substitute this u and du to our problem. So solve in solution. Copy the problem first. Secant squared x over tangent squared x plus 5 tangent x plus 6 dx. Now let's substitute. We have secant squared x dx. This is our du over tan squared x, which is our u. So we have u squared plus 5 tan x or 5u plus copy x as 6. Next, as you can observe to our problem, to this equation, we can factor this denominator, right? So we have du over factor of u squared plus 5u plus 6, u and u, 2 times 3, we have 6, so u plus 2 plus 3, u plus 2 times u plus 3, right? So to integrate this equation, we can apply case 1 in partial fraction, right? So let's proceed to applying partial fraction. So copy first the du over u plus 2 times u plus 3. Applying the partial fraction, we know that du, it has a coefficient of 1, right? Over the denominator, u plus 2 and u plus 3 is equal to a over the u plus 2 plus b u plus 3. Now, let's multiply both sides by this denominator. So u plus 2, u plus 3, multiply u plus 2 and u plus 3. So let's multiply. Cancel. So 1 is equal to a over u plus 2 times u plus 2 times u plus 3. Cancel the u plus 2. The remaining is a times u plus 3 plus b over u plus 3 times u plus 2 times u plus 3. Cancel the u plus 3. We have b u plus 2. Next, let's distribute the a and b. So a times u, we have au plus a times 3, we have 3a plus b times u, we have bu, b times 2, we have plus 2b. Now let's separate the um, the letters that has coefficient. So 1 is equal to AU plus BU plus 3A plus 2B. Now, next, let's find the value of A and B. Now, to find the value of A and B, we know that AU plus BU is equivalent to UB plus A, or A plus B is equal to A plus B is equal to 0, right? And 3A plus 2B is equal to 1. A plus B is equal to 0. This is our equation 1. And 3A plus 2B, it is our equation 2. Now let's use this two equation to find the value of A and B. So again, we have A plus B is equal to 0. This is our equation 1. And 3A plus 2B is equal to 1. This is our equation 2. Now let's use this two equation to find the values of A and B. Now let's start with equation 1. A plus B is equals to 0. So we have B, the value of B is equal to, transfer A, we have negative A. Now this is our equation 3. Now let's substitute equation 3 to our equation 2. So we have 3A plus 2B is equal to 1. Now 3A plus the value of B, so 2 times negative A is equal to 1. Now 3A plus 2 times negative A, we have negative 2A, right? Is equal to 1. So it can be 3A minus 2A is equal to 1. Next, we have 3A minus 2A is simply A is equal to 1. Now, this is the value of A. So A is equal to 1. This is now our equation 4. Let's substitute the value of A to our equation 3. So B now is equal to negative, since the value of A is 1, so negative 1. So this is now our value. So A is equal to 1 and B is equal to negative 1. Now, let's go back to our this equation. Now, A over U plus 2 plus B over U plus 3. Don't forget the integral and du. Now, let's substitute these two values in our problem. So, integral of the value of A is 1 over U plus 2 plus the value of B, we have negative 1 over U plus 3. Don't forget the du. Next, integral of 1 over U plus 2. Positive times negative 1, we have negative 1 over U plus 3 du. Now let's integrate. But first, let's separate. So 1 over U plus 2 minus integral of 1 over U plus 3. Don't forget the du and du. So the integral of 1 over U plus 2 du is simply ln U plus 2 minus integral of 1 over U plus 3 du is simply ln U plus 3 plus C, since the integral of du is plus C. Next, since it is subtraction, it can be rewritten as U plus 2 over U plus 3 plus C. Now, remember the value of U and du, since our U is equal to tan x, right? So let's substitute the value of U to our answer. So ln tangent x plus 2 over U, tangent x plus 3 plus c. This is now our final answer. ln tangent x plus 2 over tangent x plus t plus c.